Okay, so Leetcode practice time. So in this video there are two goals. The first one is to see how to solve this problem, then we are going to do some coding work. And the second goal is to see how we should behave during a real interview. Suppose this is some real problem in a real interview. So let's get started. So first of all, the first step in a real interview is always try to fully understand the problem. If there is anything unclear, please bring up the questions, and also at the same time think about some edge cases. So let's take a look at this question. So construct binary tree from string, and you need to construct a binary tree from a string consisting of parentheses and integers. So the whole input represents a binary tree. It contains an integer followed by 0, 1 or 2 pairs of the parentheses. Okay, so the whole input string represents a binary tree. It contains an integer followed by 0, 1 or 2 pair of the parentheses. Okay, so the integer represents the root's value, and pair of the parentheses contains a child binary tree with the same structure. Okay, so you always start to construct the left child node of the parent first, if it exists. Alright, so let's take a look at this input example. For this one, we are going to get a tree something like this. Okay, and it says that the string length is between 0 to 30k. So S consists of digits, the open and closing parentheses, and the dash. Okay, so dash means it's negative. Alright, so I think I pretty much understand the problem. So it is using the open closing parentheses to represent the depths of the node in the tree. Okay, so let's think about some edge cases. So the first edge case I can think is it is an empty thing. So it is if it is an empty string, then we just return non-pointer. So other than that, I think the next thing I can think about, what if the input is not valid? So if it's not valid, so for example, let's say the input string is like then 4 followed by closing parentheses, then it may not be valid. So but we need to make sure that this input, whether this input exists or whether this input exists or not, or whether we need to deal with this kind of cases. So for example, 4 followed by 2 closing parentheses. So of course this is not going to be a valid input. But anyway, so let's assume this kind, we are only going to deal with the valid inputs. So the next thing is to find a solution for this one. So what will be the solution for this question? So based on what I can see, I think we could use some recursion. So it's like we define this one as a recursive function. The exit is so the exit is if it is empty string, then we are going to return none. So otherwise, so for example, this layer, it returns the root of the tree, and this layer, it returns the root of the left subtree, and this layer returns the root of the right subtree. So if you use recursion, it is pretty natural that this is a well-defined function. But the disadvantage to use recursion is that you need, so in each recursive function you need to extract the corresponding substring explicitly. This is going to take some time to do it. So instead, so the recursion is always based on top of the stack. That's what we learned about recursion in the classroom. So let's think about, instead we can use some stack to solve this problem. So if it is a stack, so when we encounter a number, then we just put it into the stack. And when we encounter a open parenthesis, we pretty much don't really need to care about it. And when we encounter a closing parenthesis, then it's time for us to pop the node from the stack. So take this input as an example. So for example, we encounter the 4, then we create the node and insert it into the stack, and then we encounter a open parenthesis. We just leave it as it is, just goes past it. And then when we encounter 2, it's actually the root of the left subtree. So we are going to create the corresponding node and pick the top element from the stack. So if the top of the element has the left node already, left child already, then we are going to assign it to append this node as its right node. Otherwise, we just treat it as a left node. So for example, for this one, this 2, we pop the node 4 from the top of the stack, and then we assign its left child to be this node, so on and so forth. So overall, the runtime for this approach is gonna be linear to the length of the string, because we just need to do one pass of the string, and each time we just need to pick the top element of the stack, which is a one operation. So this is a linear approach, and next step, after we get an agreement with the interviewer about the solution itself, it's time for us to do some coding. So for coding, don't be too slow, and also care about the correctness and your readability of the code. So let's get started. Remember, the first one is if the string is none, or as the string.length is equal to a 0 thing, then we are going to simply return non-pointer. So otherwise, we are going to have the stack. So the stack contains a node. Okay, so it's called tree node. So its stack is equal to new stack, the tree node. Alright, so that's the stack. We will need to have the index of it. Alright, so so let's say index is equal to 0. So the index is smaller than s.length. So this is a while loop, and first of all we will need to we will need to see if it is, so there are several different things, like if it is a digit, or if it is an open parenthesis or closing parenthesis, or an inactive thing. So I'll say so s.car, so maybe you can get car c as s.car at idx. So if car let's say if character dot is digit c, or c is equal to a minus, then it means we already encounter some number. So remember, we are not dealing with legal input. So for example, let's say we don't have something like this one, so this is going to be illegal, and we are not just going to deal with that. So if it is a digit or an active thing, then we are going to say, so idx plus 1 is, so I would like to see if the next one is also a digit as well. So let's see. So int num, let's say this is the start index of the number. Start, so num start idx is equal to idx, and enum and idx is equal to idx. So well, num and idx is smaller than s$length, and character dot is digit, as digit s.car at num and idx. Then it means that, so we are going to just plus the num and idx, and finally when num and idx is, so when this while loop is jump out of it, we are going to get a number. So int, let's say node value is equal to integer dot parse int this is a substring, the start index is num start idx, and then this is num and idx. Alright, so yeah, so we have the node value, and node we have the node value, so we are going to create the tree node. Node is equal to new tree node, the node value. So the stack, let's see, so if stack dot peak, so the peak, I'm not sure. So if stack not stack dot empty, so if it's not empty, then we are going to peek the stack, so we are going to get a node of it. So tree, let's actually see if stack java peak, so if the stack is empty, what the peak is going to get us. No, this is not the JDK. Okay, so it says that peak is going to get us the E, so it's going to throw an exception if it is empty, so we definitely need to see if it is empty. The tree node, let's say root is equal to stack dot peak. So if the root dot left is not equal to a num pointer, then we are going to say, okay, root dot right is equal to the node. Otherwise, alright, so it's really weird to do it in this way. So actually we can just do it, if it is equal to none, then we are going to say left is equal to this one. Otherwise, right is equal to the node. Alright, so we have this already. We assign the node to the top, to the left or right child of the top element of the stack, and next thing for us to do is we are going to push it into the stack. So this is add the node. Okay, otherwise so if it is an open parenthesis, we don't need to care about it, but definitely if the character, if it is a closing parenthesis, that is the time we need to pop the top element from it, because we just finished one layer of the node, of the tree, of the subtree, to be exact. And finally we are going to return stack dot pop. So that's essentially how the piece of the code is essentially about the coding. So after you're done with coding, remember it's not the time you're done with the interview, so you still need to do some testing. So first step is you do some sanity check, and by going through an example, and at the same time you explain how the piece of code is going to work to the interviewer. And after that, you will need to say you want to introduce some test coverage. You need to introduce some extra test cases to cover different branches so that you have good enough test coverage. So let's see. So for this example, let's go through it. So it is a stack. So the stack is going to be empty at the very beginning and index as 0. And I think I do have some mistake here because I didn't really plus the index. So actually here what we should do is we should have idx is equal to num and idx, and then we are going so it should be something like this, and then we continue and the same here. We just need to plus idx. So I think that is a bug. Glad we catch it. So let's take a look at this one after we made the code change. So first of all, idx is equal to 0. We get, so the first one is 4, so it's definitely a digit. So num start index is 0. Num end index is equal to 1. So this one is definitely not a digit. So this while loop is not going to do anything. So we are going to say, alright, so the node value is 4. And we get a new node. So currently it is empty. We just need to push the node into the stack and have idx as 1 at this moment. And next time we encounter a closing parenthesis, because currently this is 1, so we have this. Idx is equal to 1, so we just plus idx. When it is 2, then we jump into this if branch again. So it says num start idx is equal to 2, and this while loop is going to do nothing, and we get the node value as 2, and we assign the top element's left child as node 2, and then we are going to, so the tree is something like 4. So it's something like this at this moment. And then we are going to have 2 inserted into it. So similarly we have we will have the thing which is this one, something like this for the tree. So and then when we encounter the 1, is because the root node which is okay, so we encounter so that will be something like that. So when we encounter closing parenthesis, we are just going to pop this top element from the stack. So it is done, and when we encounter 1, we are going to assign it to its right, to this node's right child. So I think it generally works. Let's give it a shot by run this piece of code. So I would say this should work. Let's see if this is going to get us something surprising. Alright, so no surprise. Let's do a submission for it. Alright, so I think we are good with this piece of code. So the only thing is that this piece of code is not going to deal with the illegal input while. So for example, if it is something like this, it is going to just break. Yeah, so this is just still going to break, but remember to always clarify with your interviewer whether there could be something illegal in the input. So for this specific problem on this platform, it seems like we don't encounter that case, but in the real interview, this may not be the case. So I would say regarding the test coverage, definitely have something like the empty thing, the empty string input, and also have some input like this, and also have some negative integers in it. Other than that, I would say we should be good enough regarding the test coverage. So that's it for this coding question. If you have any question about the solution itself, please leave some comments below. If you like this video, please help subscribe to this channel, and I'll see you next time. Thanks for watching.